Hey, we have here today a homemade integral. I'm going to try to solve this using the beta function. We have the integral from 0 to 1 of x to the 1/6 times 1 minus x to the minus 1/6 dx. Okay, like I said, we're looking to solve this using the beta function, so let's just go over that formula right now. We have this integral from 0 to 1 that's in exactly the same format as what we have here. We have these exponents, and what we're looking for is this z1 and z2 value. What this allows us to do is basically go directly to a solution in terms of the gamma function that we have here. And then with a few formulas that relate the gamma function to the factorial, it makes this usually pretty easy to calculate. So let's get right into it. And what we need to do is we just need to find these values for z1 and z2. And we're just going to focus on our exponents here, 1/6 and minus 1/6. So we're saying if z1 minus 1 is 1/6, then that's going to mean just a little rearranging. z1 must be 7 over 6. And then doing the same thing for z2. z2 minus 1 is minus 1/6, so we can add a 1 to that and we find that z2 is going to be 5 over 6. Then we'll go right to our solution in this form. So we're going to have, this is going to be the same thing as gamma of 7 over 6 times gamma of 5 over 6. Then we're going to have the sum of these. Adding these together, it's going to be gamma of 12 over 6, which is 2. Now this piece is going to be easy because we can go right to this formula that puts us in terms of a factorial. So gamma of n equals n minus 1 factorial. Gamma of 2 is 1 factorial, but that's just going to be 1. Now this is a little tricky because each of these values separately are difficult to find. Actually, let's just focus for a moment on gamma of 7 over 6. So this is going to be the same thing as n minus 1 factorial. So this is going to be the same thing as 1/6 factorial, 1 over 6 factorial. But that can be written as 1/6 times minus 5 over 6 factorial. But this is actually gamma of 1/6, so we can rewrite this. But this here is actually going to be gamma of 1 over 6. So we can have our 1 over 6 in front, and we can rewrite our gamma of 7/6 as 1/6 gamma 1 over 6, and then we'll just bring down our gamma of 5 over 6. And now from here, you might think this is kind of pointless because we still have these two values that we don't know how to calculate. But what we can do is use Euler's reflection formula, and that's going to help us now. Okay, so we have this formula for Euler's reflection over here on the right. And now you may notice why I did this, because now 1/6 and 5/6 sums to 1, the same way z times 1 minus z sums to 1. So I was just manipulating it to get it into this form where we can use this formula. And so let's do that, but we just have to have our 1/6 in front. Then using this, we're going to have pi in the numerator. We'll call this our z 1/6, so we're going to have sine pi over 6 here. But we know this value is actually just 1/2. So we're going to have 2 pi over 6, but that's actually going to reduce to just pi over 3. So that's it. We'll stop it there. Thanks everyone for watching. Have a great day.